You know, when you look up at those giant transmission towers, have you ever really wondered why there are always wires in sets of three? It's not just a random number. Nope, it's actually the blueprint for an invisible, rotating force that powers pretty much everything, from huge factories to the very device you're watching this on right now. So today, we are going to pull back the curtain on that force. Three-phase power.
But to really get it, we've got to start with a question that sounds, well, impossible. How in the world do you spin a metal egg without touching it? I know, it sounds like some kind of magic trick, and honestly, in a way, it is. And the answer is the key to understanding our entire electrical world.
All right, let's get into it. This so-called trick was first pulled off by the one and only Nikola Tesla. And the magic that he used is something called a rotating magnetic field. If you can wrap your head around how he created this invisible spinning force, you're on your way to understanding how basically every electric motor on Earth works.
So how do you actually build this thing? Well, if you just use one electromagnetic coil, the magnetic field it creates just pulses back and forth. It can pull something, sure, but it can't make it spin. Okay, so you add a second coil, kind of offset from the first. Now you're getting somewhere. You get a rotation, but it's wobbly and uneven. But here's where the magic happens. You add a third coil. With all three positioned 120 degrees apart, their magnetic fields all blend together to create this perfectly smooth, constant rotating force.
And this is the exact thing Nikola Tesla showed off at the 1893 World's Fair. He set up his three coils, put a copper egg right in the middle, and turned it on. That rotating magnetic field created currents inside the egg, which in turn created its own magnetic field, and the whole thing started spinning so fast it stood right up on its end. It must have looked like sorcery, but what people were really seeing was the birth of the modern AC motor.
So that raises a question, right? If you can get a magnetic field from just one coil, what we call single-phase power, which is what comes out of your wall outlet, why don't we just use that for everything? Why go through all the complexity of three? Well, it turns out single-phase power has a really big fundamental problem. And that problem is that its power delivery just isn't constant. It comes in pulses. I mean, think about it. The voltage in a single AC wave goes from a peak down through zero to a negative peak and back through zero again. Every time that voltage hits zero, for that split second, absolutely no power is being delivered.
This chart really shows you the roller coaster ride of single-phase power. Yeah, it hits a peak, but twice every single cycle, the power delivered drops all the way down to nothing. Zero. For a motor, that means the torque, the rotational force, is jerky. It's like trying to push a merry-go-round with a series of separate, jarring shoves instead of one smooth, constant push. It's just not efficient, and it causes a ton of vibration.
And this is where the magic of three comes roaring back in. Three-phase power solves this pulsating problem with just incredible elegance. By using three separate AC waves, each one 120 degrees out of sync with the others, the system delivers perfectly smooth, perfectly constant power.
The idea here is actually beautiful. Just as one of the three waves is getting weak and approaching zero, the other two are near their peaks, delivering tons of power. They perfectly fill in each other's gaps. It means that at no single point in the cycle does the total power delivery ever drop to zero. It's just a steady, constant stream of energy.
I mean, the contrast couldn't be clearer. Single-phase gives you pulsating power and jerky motors. Three-phase gives you constant power and smooth motors. This is exactly why it's absolutely essential for any kind of heavy-duty work, from giant industrial machines to the electric car in your garage.
Okay, so constant power is a huge win. But believe it or not, there's another, even bigger benefit to using three phases. It's a secret that saves an unbelievable amount of money and materials, and it's the real reason our power grid looks the way it does.
Here's the number you need to remember: 50%. To send the exact same amount of power, a three-phase system needs half the amount of copper wiring compared to what you'd need for three separate single-phase systems. In an industry that uses millions and millions of tons of copper, that is a massive, massive deal.
So how is that even possible? It's because a three-phase system is what engineers call a balanced system. Since those three currents are all perfectly offset by 120 degrees, at any given moment the current flowing out through two of the wires is perfectly balanced by the current flowing back through the third one. If you add them all up at any instant, the sum is always zero.
And here's what that means in the real world. Because they're all balanced, each wire acts as the return path for the other two. You don't need a separate return wire for each one. So instead of needing 6 wires, an out and a back for 3 separate circuits, you only need 3 total. You literally get to throw away half the copper. That is why you see 3 main lines on those big transmission towers. So how do we actually wire all this stuff up?
Look, we're not going to get lost in complicated circuit diagrams, but there are basically two main ways to connect everything in a three-phase system.
They're called the star or Y connection and the delta connection. And yeah, they're named for the shapes they make. The star connection brings all three phases together at a common central point, which we call a neutral. The delta connection just links them end to end in a big triangle. They each have their own specific uses, but they are the two fundamental building blocks of the entire grid.
Okay, let's zoom all the way out here for a second. This idea is over 130 years old, but it's not some dusty historical fact. The principles of that rotating magnetic field and the balanced three-phase system, well, they're the absolute bedrock of our modern world.
It is the invisible foundation of our entire high-power world. We're talking about the national grids that send energy across continents, the factories running all that heavy machinery, the data centers that power the internet, and of course, the electric vehicles and fast chargers that are totally changing how we get around.
When you get right down to it, three-phase power is so much more than just a clever engineering trick. It's this beautiful lesson in how three interacting forces, when they're perfectly balanced, can create something far more powerful, smoother, and more efficient than any of them could on their own. It is a masterclass in elegant problem-solving.
It's this unseen force that quietly, efficiently, and elegantly powers our entire world. So the next time you look up and see those three wires stretching out to the horizon, maybe you won't just see cables. Maybe you'll see the physical proof of one of the most brilliant and impactful ideas in human history.